Now I'm going to talk about the difference between the continuous measurement and the burst measurement. These are the two types of main measurement, especially when we are measuring the signals, waves, and we have to decide which one we are going to use. First, I start with the continuous measurement. It means that whenever we have the data, when we have the signals or wave or whatever we want to measure it, we keep measured over time without any stop. Just keep measuring it until the end of the measurement. There's no gap in the measurement, in other words. So, for example, assume there's a time and we have a signal that is moving here. So, any type of signal, so I assume I have it that goes ahead over the time. And then we want to measure that. So assume that we have some kind of signal over time, we want to measure that. So and these are the times. So I'll go ahead and say, so assume this is the start of the time. It's going to be 1 hour, it's going to be 2 hours, and 3 hours, 4 hours, and 5 hours. Assume we have the signal and we want to measure it over the 5 hours length, and that signal, I'll just make it simpler like that. We have a simple signal that it keeps going over 5 hours of length, and we want to measure it. So we just set up our the sampling frequency of our let's say instrument, and we will ask the instrument to go ahead and start recording. So for example, if I go ahead and says assume my sampling frequency of the signal is 10 Hz, so I'm gonna have 10 Hz sample frequency, and I record for 5 hours, and the total time, the total duration is 5 hours. See how many data points I'm gonna have. Basically, it means when I have 10 Hz, it means that in every second I measure 10 data points. For every second of signal, I measure 10 data points. Or in other words, every second of this signal is represented by 10 data points. So basically, we tell our instrument if this is the 10 Hz, it means that the delta t between every 2 delta points is 1 over fs, and is going to be 0.1 second. So every 0.1 second is going to measure 1 data point, and then next 0.1 second, next 0.1 second, next 0.1 second, measure data point. So in total data points we have are equal to total time that we have, which is going to be 5 hours times, it's going to be 60 minutes, and every minute is 60 seconds. So it's going to be the total time. So it's the total time, and then times by sampling frequency, which is going to be 10 Hz. So it's going to be our fs, and whatever is the result of this is the total number of data points we are gonna have in our measurement. So in total, in this case, we are gonna have 180,000 data points for our measurement. Most of the time, just remember, we cannot analyze the whole data set like that. Although we are measuring continuously from time 0 to 5 hours, in most cases it's not possible to analyze data like that. We have to break it to the smallest portion of data, because the data is not going to be stationary. They're going to be trend in the data. It's going to go up and down. So we have to break it into the smaller. So for example, we need to break it to 1 over 1 over 1 over 1, or so maybe we need to break it into the 5 sections when we want to analyze it, or we may need to break it into the half an hour and then analyze every half an hour separately, or every 15 minutes separately, depend on the physics of the data. But in most cases is not practical, or it's not correct to analyze the entire data set all at once. So although we measure it continuously over the period we want, but we cannot, but we don't analyze it like that. The second format of the measurement, which is probably most useful when we are measuring outside the lab, they call it the burst measurement. So it's called the burst measurement. In the burst measurement, the difference between burst measurement and continuous measurement is that we are not going to measure continuously. In other words, we measure for a while and we stop for a while, and then we measure for a while and then we stop for a while. And the reason for that is that when we start to measure data, there are two main limitations we may face. One of them is the memory. So if we keep measuring data, we run out of memory. And the second is the power. If you are in the lab, most of the time these two are not that problem because our instrument is connected to the outlet, so it has a stream continuous power. So we are not going to be worried about running out of the battery, and we can have the very large storage, so we are not going to be worried about the storage either. But if we measure outside in the field or outside the lab, which mainly the instrument works on the battery and then store the data on the internal storage, then it's not easy to do the continuous measurement, because if we do the continuous measurement, after a very short while, we will run out of the memory or we will run out of the battery. So we have to preserve the memory and battery, both of them. Because of that, we can't go ahead and start continuous measurement, and we need to do the burst measurement. Now if try to show how do we do that. So I draw that axis again here, the time axis we have, and then we have that hourly mark. So it's 0, 1 hour, 2 hours, 3 hours, 4, 5 hours, and then as soon we have a way we want to measure it, and we are outside in the field. So again, I'll put this simple wave here. If you want to measure over the 5 hours. In this case, when we want to measure, we will set up our instrument, but we don't tell it to go ahead and start to measure it continuously. Instead, what we'll do is tell that, okay, start at the time 0. And for example, for this case, I will tell him to go for 20 minutes, measure data for 20 minutes. So it's going to be 20 minutes. And then go to sleep for about 40 minutes. So it just up to here, 40 minutes, just do nothing. And then at the start of the next hour, again wake up, measure for 20 minutes. Again, measure for 20 minutes. And then by the time we get to 20 minutes, again go back to the sleep for 40 minutes. This is 40 minutes. So go back to it for 40 minutes and basically do nothing. Sleep. Again, at the start of the 3rd hour, wake up and measure 20 minutes. The same, and go to sleep. Then at the start of the 3rd hour, measure for 20 minutes. And the start of 4 hours, measure for 20 minutes. So this is 20 minutes, 20 minutes, 20 minutes. And then for each of them, sleep for 40 minutes. Between each of them, just sleep for 40 minutes. In this case, I measure 20 minutes, sleep 40 minutes, measure 20 minutes, sleep 40 minutes. Still, I have the very same measurement here. I would say that, okay, the sampling frequency is going to be 10 Hertz. But this time the burst duration, this one we have this, instead of the total duration we have the burst duration, and the burst duration is going to be 20 minutes here in this case. So total data point in one burst is going to be the length of the time, the length of that burst is going to be 20 minutes times 60. This is 20 minutes times 60. So it's the burst duration. That's the burst duration, and times 10, which is going to be the sampling frequency, which in this case is going to be 12,000 data points. So what we have is the each burst of our data is 12,000 data points. How many bursts we have? So this is going to be the first burst here, second burst, and so this is the first burst, second burst, third burst, fourth burst, and fifth burst. So the number of bursts that we have, the number of bursts that we have, number of bursts here is going to be 5. So we have 5 bursts stuff data, which each burst is 20 minutes. So each 20 minutes here represents that 1 hour data. So in here, when we have it, this 20, when we analyze these 20 minutes, we'll say whatever we get out of these 20 minutes is, for example, assume we measure wave and we analyze these 20 minutes and we comes up with the wave height and wave period. Whatever we get from these 20 minutes, we will consider it for that entire hour. Whatever we get it here, for consider for that the second hour. In the continuous mode, as I said, we might come out and break it into, for example, 1 hour block or half an hour block. If we break it into 1 hour block here, so we analyze that 1 hour block, and whatever we get from that 1 hour block here, if I can assume this is a wave, we break it to the 1 hour block. Whatever we get from that 1 hour block is going to be wave height and wave period for that 1 hour. Then the second hour, we have the data for the entire hour, second hour. We analyze it. Whatever we get, wave height and wave periods represent the second hour, and so on. Here, instead of having the entire instead of having the data points for entire hour, we have only data for 20 minutes, and then we consider that as a representative of that entire hour. In this case, it helps us to save the memory and save the power when we are measuring, and when we have the limitation with the memory or power. Again, one more time, in the continuous mode, we measure continuously without any delay, and after we did all the measurement, we break it into the block of data. For example, we break it into 1 hour data, and then we analyze each block separately, and whatever is the result represent that block. In the burst mode, instead of measuring continuously, we measure for a short period of time, then we go to the sleep, and then we measure for a short period of time, then we go to the sleep, and so on. And then that time that we measure the data is going to be represent the entire that block that we're supposed to measure what we didn't measure, and that's the burst mode. So this is the difference between the continuous measurement and the burst measurement.